This technique may be a strategy to help minimize how much of that water, how much of that nitrogen gets pushed down past the root zone where plants can't access it anymore and becomes a problem for groundwater. Does this have water quality benefits? If it does, can we do it without negatively impacting yield? If that's successful, how do we scale it up to make it economical at commercial kind of scales?
Well, hello everyone. My name is Guolong. I'm an outreach specialist at Ag Water Quality Program with University of Wisconsin-Madison Division of Extension. Today I'm here with my colleague Kevin Masarik from Extension. Kevin, why don't you take a moment to introduce yourself?
Sure. Kevin Masarik. I'm a groundwater specialist at the Center for Watershed Science and Education. That's a partnership between the UW-Stevens Point and UW-Madison Division of Extension. We work on water quality issues statewide, helping to understand kind of ways in which we can both protect the groundwater, but also understand the impact on, let's say, private wells or drinking water sources.
Can you tell us a little bit about where we are and why we're here?
Yeah, so we're in central Wisconsin, which is known for growing potatoes and vegetables. We have a lot of irrigation, high capacity wells, because we have such sandy, coarse textured soils, which make great ground for growing potatoes, but are really challenging soils from kind of a nitrogen management standpoint. Mm-hmm. They don't hold on to water very easily or readily, and they don't hold on to nutrients very well either. So, those things combined with the high nitrogen requirements of a potato system mean that there's a high potential for nitrate loss to groundwater. And we're out here investigating ways that we can help improve groundwater quality, still have viable agricultural systems, but find ways to minimize the impact that these systems have on the environment, particularly the groundwater in central Wisconsin. So we worked with the farm here to plant, just to interplant crops, interplant different species of vegetation in between the rows of potato, which we know are susceptible to losing water. They concentrate water flow. They flush nutrients very easily out of that furrow. So this technique may be a strategy to help minimize how much of that water, how much of that nitrogen gets pushed down past the root zone where plants can't access it anymore and becomes a problem for groundwater. So we just set up a kind of a Latin square design, we call it, where we have 5 different treatments replicated in both the row and the column, where we have a control plot where it's business as usual, where we didn't do any sort of interplanting. And then we have 4 other plots where we planted, in some we planted barley, in others we planted rye. There's one we planted millet and oats, and then there's another plot where we planted essentially all of them together. And we're trying to investigate, what are the impacts of interplanting on the yield, but also between treatments, what are the different amounts of nitrogen uptake that we're seeing. So the goal is that these different interplantings are taking up nitrogen that would be normally lost. So we're trying to quantify how much of that nitrogen gets taken up by the tuber, how much of it gets removed during harvest, and then how much of it is sequestered in that interplanted biomass, that we can then see, are there differences between these plots? And the goal is to try and quantify both the impacts on the potato yield and the economics or the profitability, and see if there's any negative influence on those factors, and then try to quantify the positive environmental benefits in terms of additional nitrogen uptake that we might not see in the control plots where we're not implementing this practice.
As you know, growers in the Central Sands have plenty of experience working with cover crops being planted after the potato season.
Yeah.
What are some advantages of basically planting cover crops in between the potato rows compared to just planting cover crops in the shorter seasons?
Yeah, so great question. And we know that every year is a little bit different. So for those years where it's maybe a little bit wetter, having something growing in between the rows during the season might help minimize how much water is moving past. But then we're also, trying to investigate, are there other benefits? Uh, when we see these potato canopies starting to senesce, there's no cover and there's a lot of solar radiation that's hitting these hills, and that additional heat might not be great for the potatoes. So by having this vegetation in there, one of the questions we're also trying to collect some data on is there some sort of shading effect from this vegetation that might be helping keep more moderate temperatures in the potato hills during that time when they're starting to prepare for storage. So we are interested in trying to understand, are there other tangible benefits from this practice that might be other reasons why a grower would consider implementing it into their rotation.
And it looks like we're still at the research scale when it comes to interseeding in potato cropping systems. What are some potential challenges for us to scale this up into something that a farmer can grab and go?
For sure, there's definitely concerns in terms of harvest time, right? We have a lot of additional biomass in this field, which can maybe be a challenge when you're digging. It's going to probably be a challenge when they're trying to get the potatoes into the truck, and they're having to worry about, are the additional residues, are they causing the harvest to essentially lose potatoes that would normally be captured during that process. So understanding how this additional biomass impacts harvest is an ongoing concern that we have, and trying to understand from a management standpoint, is this something that could be overcome with technology at some point? I think our first goal was to see proof of concept. Does this have water quality benefits? If it does, can we do it without negatively impacting yield? And then if that's successful, how do we scale it up to make it economical at commercial kind of scales, at a field scale? So our plots are relatively small, so we're still planting them with kind of a one row hand plant system. So in addition to the harvesting, there's the scaling issues and concerns revolving kind of the establishment as well, and how do you do that in a way that's cost effective? Should
Absolutely.
this be a viable practice? I think scaling it up is something that we'd need to explore further.
And very timely with the time when we are recording this video, we just finished the sampling for this whole season. Any exciting things that you saw throughout this season with this interplanted trial?
Yeah, each year is, again, very different, but this year the amount of biomass, the amount of above ground biomass we're seeing at this farm is significant. This is probably the best establishment, the best above ground biomass that we've seen from the times that we've tried this practice. So that's really exciting. I think we're still going to need to work up the data on the yield side of things to see, can we parse out some of that variability? If we're seeing differences in tuber yield, where are those differences coming from? Can we attribute it to the treatment effects that we're hoping to investigate or understand? So there's more to come, but in terms of how the interplanting did this year, we were really excited. I'm really excited about what we're seeing, and I think it'll be a great data set that will help us better understand if this is a viable practice for potatoes. Some of the research questions that I would have is, are there other species that we might want to consider? Rye did really well, but looking at the root system, looking at the root mass, there might be some challenges for harvest. So are there other species that would give us significant above ground biomass, but might be easier from the harvest standpoint? Every year, again, is a little bit different, and we're learning things each time that we want to tweak. And I'll probably think long and hard this winter about um, how do we implement some additional research questions into this to try and better understand its implications.
Yes. Well, I'm really excited to see where the future of this project takes us, and thank you so much, Kevin, for your time today.
Thank you. It was a pleasure.